This is the setup for the Trigonometric Plane Curves worksheet. Depending on your version of GeoGebra, your interface may look a little different. I'm going to show it using another version, but if you have this version, this is the desktop version, the key things you need to know is that the File, Edit, and View menus live up here, and we're going to be using those, and also that your input box is down there. You probably already know these things, but I just wanted to clarify that. Now let's jump over to the other version. All right, here's the version of GeoGebra that lives on the web and on some touch-friendly devices and things like that. In this case, the menus are all over here in the upper right. Now you click on those three lines there, and you see a file menu, an edit menu, and the view menu. And actually, I'm going to go to the view menu right now, and I'm going to open up an input bar. By default, the input is up here on the upper left, but it doesn't like keyboard input today, so I'm going to open an input bar, and now I've got an input on the bottom. So let's get started. The first thing we need is our coordinate functions. So in this case, we'll use f of t equals cosine of t. There it is. And g of t equals sine of t. And there they are. Now we don't actually need to see the component functions. What we want to see is the parametric curve defined by them. So I'm going to hide them just by hitting these circles next to them, and now we don't have to see them on the graph. Though one of them still seems to be there, but I assume it'll get the point sooner or later. All right, so what do we do next? Now we're going to graph our plane curve. We're going to type in the curve function, which it offers to complete for us, but I've memorized the curve function, so I know that first I'm going to put in f of t is going to be my x-coordinate, comma, g of t is going to be my y-coordinate, comma, t is my parameter, and I'm going to go from 0 to, say, 20 or so, and that's going to be sufficient for all the curves we're going to be looking at in class. And then it's going to tell me I forgot my comma. There we go. And this is a circle, just as we saw in the previous section. It looks lovely. It's not in the instructions, but I don't need to see the label for this circle, so I'm going to maybe go up here and tell it not to show me the label anymore. All right. Now, if we want a tangent vector, we're going to define a variable which is going to determine where on the circle the tangent vector appears. We define the variable by inputting t equals 0. And now we have this little slider here. Now, if you don't have a slider here, that's fine. You just have to make it visible. So I'm going to hit this little visibility sphere there, and bam, now we've got one on the graph that we can work with. We actually want to edit the range of this variable. By default, it goes from -5 to 5, but we'd like to change that. So I'm going to select it, so it's selected. And then I'm going to go over to the to the edit menu, and I'm going to pull object properties. You can also just get this by right-clicking on the object if you have a mouse. All right, so here are some object properties over here. The slider tab across the top is what I'm looking for. And here you can set the min and the max. So I'm going to set the minimum to be 0. I'm going to set the max to be 15. You can make the increment whatever you want. You want it to be fairly small so that this is how far it goes with each tick. So if you set the increment to 5, it would just go 0, 5. Oops, lost it. It would just go 0, 5, 10, 15. I'm going to make it 0.01 because computers don't care how small you make the increment, they can handle it. All right, and now I can close these properties over here. And so now t starts at 0, and we can drag it anywhere we want between 0 and 15. Of course, it doesn't do anything yet. All right, now let's actually find the point where we're going to have our tangent vector. The way we do that is by assigning the point capital P equals, and then we're going to open parentheses. The x-coordinate will be f of t, and the g-coordinate will be g of t. And we hit enter, and now we have this point. And now, since this is tied to the variable t, if I slide t around, you'll notice p goes around and around and around the circle, which is what we want. So there's the point. Now we do the tangent vector. The good news is that GeoGebra can take derivatives for us, so we can just put in u equals. It's a lowercase u because this is a vector. It's rounded brackets because GeoGebra likes rounded brackets for both vectors and points. And we can just tell it, well, for the x-coordinate, use f prime of t, And for the g coordinate, for the y coordinate, use g prime of t. And again, as long as your functions are functions that it recognizes, GeoGebra will take those derivatives for you. And there we can see the vector in the center of the circle. I can actually zoom in a little bit so we can see a little better what's going on here. And so as t goes around, that tangent vector goes around as well. Now you notice it's not in the right place. And so that's where we have to use the vector from a point function. The vector from the point function lives up here on the line menu. So you can select line, say, well, vector from a point is the one at the bottom. So we select that. And it tells us we want to pick the point, to click then on the point, and the vector we want to extend from that point. So we will have the vector start at P. So it's actually the proper tangent vector at P. And the vector we want to extend from P is the vector U. And now it's created the correct vector for us. To avoid creating more vectors by accident, I'm going to go back to the Move tool in the upper left here so that we are not continually creating more vectors every time we click on a point or a vector. All right, this is great. I want to hide a couple of things here now that aren't important. We don't need the original vector u because its replacement vector v is the translate that we need. So I'm going to hide u, and I'm also going to hide p prime because I don't really care where the endpoint of the vector is. I just want a nice picture of the vector itself. There we go. All right, so now as I spin t around, I now have the point moving around the circle, and I now have the tangent vector. This is what we want to have in place for the worksheet. Now we want to make a copy of this, of these objects, because we're actually going to want to be able to look at two curves at once. So the way we do that is we just have to select them all. You can just select one. If you've got a keyboard, Control A or Command A will then select all of them like I've done here. Alternately, you can go into the menu over here. Under Edit, there's the Select All option. And now everything is selected. And now we're just going to do a copy-paste. So back in the Edit menu, we're going to copy. If you know the keyboard shortcuts for these, those work too. And then back in the Edit menu, we're going to paste. Now it actually wants us to tell us exactly where we want it pasted, because it's not going to center it exactly on top of the previous one. So you can kind of drag it around to wherever you want. It's really not important because we're not going to use these functions anyway. And then you give it a tap or something, and you're good to go. All right, so now we have a bunch of new objects. And you'll notice from the names over here on the left that every new object has just the same name as the original object. They've just put an _1. So we have A sub 1, F sub 1, G sub 1, U sub 1, V sub 1, T sub 1. And our next task is going to take all these sub 1s and put them in a different view, the graphics 2 view. So let's go ahead and open up graphics 2. We'll go to the menu. Under the View menu, you can see the graphics menu is open right now, and that's what we're seeing. The algebra menu is where all these objects are listed, and there's also the graphics 2, which is just a second graphing surface that we can use, which has now popped over here. And you probably want to resize some of these things if you can. There we go. A little bit of equal time there. So now we've got two different graphics views side by side, and what I want to do is I want to exile all of these copied guys into graphics 2 and not have them in graphics 1. So let me show you how that works. I'm going to go ahead and select all of the new ones at once, at least all the ones that are visible. We don't need to copy the invisible things, or don't have to move the invisible things because we're not going to see them anyway. So I'm going to select P1. I'm going to hold down Control. If you can't hold down Control, I think you just have to do these one at a time, which is kind of lousy, but there's only 3 visible objects, so it won't take you that long. 4 visible objects, I'm sorry. A1, V1, and T1 I would all like to be visible. T1 actually isn't visible right now, so I'll make it visible. And then we can do what we did before and open up the object properties. You can actually get to the object properties just by right-clicking on these, on the objects themselves. But another way is to go back to the Edit menu and go to Object Properties. It's going to open up Object Properties over here, and I'll go across to the Advanced tab. Under the Advanced tab, you may have to scroll down depending on the resolution of your display. At the bottom here, you can see that this object is visible in the Algebra menu, which it needs to be if we're going to interact with it. And it needs to be visible in the Graphics menu, or it's visible in the Graphics menu. But we don't want to see it in the Graphics screen, not graphics menu. We don't want to see it on the graphics screen. We want to see it on the graphics 2 screen. So I deselect graphics, I select graphics 2, and there it is. And now I can close this. Just as a side note, our algebra menu over here is getting pretty full. Depending on your version, it might be nicely arranging these things so the functions are all together, the points are all together, the sliders are all together. It might not be doing that, and if it's not, you can open up this little menu here, clicking this, let me use the mouse, clicking this thing right here, or touching this thing right here, and going over to this sort by object over here, and you can make it sort by object type if you want. And then it'll keep the numbers together, the parametric curves together, the functions together. It'll be easier to find. It'll be easier to find each individual piece when you're editing these in class. The last thing to do is to save your file. So to do that, we again go over to the menu, we go to File, we go to Save. Now, it's going to, by default, want to try to make you upload the file onto their server and create an account and all that, but you don't need to do any of this. So you can instead just type in a file name. So I don't know, tangent, not tangent, what is it? Trigonometric plane curves, or whatever you want to call it. And then this little button right here with a little pentagon here, if you click on that, the pentagon says upload it to their site. The file says save it on my computer. So I'll just save it on my computer. And then I will save it, and it will open up a saving dialog box, though I don't think that's going to record right here. So save it wherever you want. And then after you've done that, you can close GeoGebra and open up the saved file and make sure that everything is where you left it. If everything seems to be in order, then you are ready to go.